Solutions to the second set of problems. Okay, so in the first case, what's the period of rotation? Well, if you look at the right-hand side, it does 100 cycles in 25 seconds. The period is the time for one cycle or one repetition. So divide both of those by 100. One cycle is equal to 0.25, that's the period. Okay, the next one. If the radius is 0.3, what is the velocity? Now the velocity is a vector that's tangential to the motion. It's constantly changing. So you're not able to work out a vector here. So really they should have asked you for the linear speed or the magnitude of the velocity. And if you look there at the right hand side, I've got the bars on either side of the velocity. So that's the magnitude of the velocity or the speed, and that's distance over time. The particle travels the circumference of a circle, so that's 2 pi r, and the time is the period. Fill in your values and you get your answer. Draw an arrow is tangential to the circle wherever the ball is. The one below, the period of rotation, it's done the exact same way, and the draw an arrow to indicate that. I'll show you that in the next slide. Okay, object is spun around. What's its velocity? I use the same thing here. The velocity vector is constantly changing, so they should have said the speed, or you should be asked for the speed or the magnitude of the velocity. Speed is distance over time. We're assuming one full revolution of the circle, so it completes one circumference of the circle, 2 pi r, in a time equal to the period. So fill in your values, get 1.81. The acceleration formula is just a is v squared over r. Fill that in, you get your answer. And then I've drawn the diagram of what the tangential velocity should look like for this and the previous two questions. All right, question 6. What's the period? So the period is 1 over the frequency. We're given the frequency of 10 hertz. The velocity, again, we're looking for the speed there. That's worked out. Acceleration, same as question 5. And the net force, I've just used F is equal to ma with the acceleration from part C there. All right, the wind turbine question. Through what distance does the tip move in one revolution? So if we use 2 pi r, because it goes around in one full circle, or goes around the circumference of a circle, the radius is 80, so it works out as 503 meters. The velocity, distance over time again, and I know it makes 10.5 revolutions in 1 minute. That's 10.5 in 60 seconds. So we want the time for one revolution. It's 60 over 10.5. I've subbed that directly into the second, I suppose, line there of the solution. So you get 60 over 10.5 underneath the line where v is equal to 2 pi r over t is. How long does it take for the blade to go around once? That's the periodic time. And like I said, we work that out by 60 divided by 10.5. Okay, question 9. So it's 45 RPM, that's 45 rotations per minute, or 45 rotations in 60 seconds. The time for one rotation is 60 over 45, which is 1.33. That's the periodic time. You need that to use speed as distance over time again, with the distance equal to circumference of a circle, and t being the periodic time. Okay, 10, same as the previous page, 11, the previous examples, and 11, the same as the previous examples also. All right, the last one. We know it's 4 revs in 30 seconds, so one revolution in 7.5 seconds, and the period is the time for one revolution, so 7.5 seconds. Frequency is 1 over the period, that's done. The speed, linear speed, we've worked that out a few times. We've worked out the acceleration a few times, so they're done. And then E, F is equal to ma there with the acceleration from part D, and m as 75 will give you the answer. 15, what must their acceleration be? You're given the force, given the mass, work out the acceleration. How fast must they be travelling? I've used the acceleration is equal to v squared over r. We know the acceleration from part A. We know the radius as well, so it works out there as 8 meters per second. The period, I've used v is equal to 2 pi r over t, so that's the velocity formula. Rearranged it to get the periodic time is the distance travelled, 2 pi r, over the speed. That gave me 17.5, and then how many laps will they make in 10 minutes. If they make one lap in 17.5 seconds, we want to find out how many laps are contained within 10 minutes, how many 17.5 seconds are contained within 10 minutes. So if we're asking ourselves how many 17.5 seconds are contained within 10 minutes, you need to divide one into the other, which is the right hand side of the solutions there.